Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last turn year CBSE Board Chemistry questions part 21, in which we are going to discuss the Aldehydes, Ketones and Carboxylic acid chapter. So here the question number 1 is the convert the benzoic acid into benzaldehyde. First of all, we have to write the structure of benzoic acid. This is the structure of benzoic acid. So I'll be putting a benzene ring along with one COOH group. That is benzoic acid. So I have to convert this into benzaldehyde. So I have to write the structure of benzaldehyde. So whenever this kind of a conversion is asking, you just note down the reactant and product. So then you can think about how it can be converted into products. Okay. So what are all the feasible steps to convert these to get a product? Okay. So you have to think in that way. At the same time, we have to go in a minimum number of steps. By that way, we can able to prepare, but because that is a chemically feasible and more yield giving reaction. That is what we have to choose the minimum number of steps containing reaction. So here benzoic acid. So which will be reacting with SOCl2. What is the SOCl2? It's a thionyl chloride, SOCl2. So if thionyl chloride is involved in the reaction, as we know that, if you don't know about this, please go and watch my previous video. You'll be getting good idea about this. And here it is SO. I'll be separating these things like this. So I'll be getting the product like this. This is called a benzoyl chloride, COCl. I'll be getting. Once I got a benzoyl chloride, it will be reacting with our good reagent, that is the palladium and hydrogen. With that, barium sulfate will be used. So this is called a Rosenman reduction. So if I use this, I'll be getting a product like this. This is called a benzaldehyde. So I'll be getting a product like this. Here the hydrogen palladium will be acting as a good reducing agent. But at the same time, barium sulfate. Why we have to use the barium sulfate? Because the barium sulfate, which will be acting as a poison to avoid these kind of reaction. If further reduction will not be occur, if I use, suppose if I am not using barium sulfate, these reaction may happen. Suppose in presence of barium sulfate, this reaction will not be happen. So which will avoid the further reduction reaction. That is what we are using barium sulfate. The barium sulfate will be acting as the poison to this product. That is what which will not undergoes the further reduction reaction. Are you able to understand, student? That is what we are using barium sulfate. And next question is aldehydes and ketones have lower boiling point than that of the corresponding alcohols. Why? Because usually the boiling point entirely depends on, so they are clearly mentioned that aldehydes and ketones, their corresponding alcohols. So if suppose if I am taking alcohol, suppose if I am taking ketone, CH3, CH2, C double band OH, this is an aldehyde. Okay, 3 carbon containing aldehydes and CH3, C double band O, CH3. This is a 3 carbon containing ketone. So suppose say same thing, CH3, CH2, CH2OH. This is a 3 carbon containing alcohol, which one is having higher boiling point. Because according to the concept, as per the molecular mass, almost the same molecular mass will be existing. But the thing is, here it has only weak, what is the dipole-dipole interaction. In both these cases, they are having only dipole-dipole interaction. So they are having only dipole-dipole interaction. Are you able to understand, student? It's a dipole-dipole interaction is there. But in the case of alcohol, it has intermolecular hydrogen bonding. Not to be intra, it's an intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Okay, are you able to understand, students? So because of the hydrogen bonding, it will be very strong enough to break, so that we need to supply more amount of energy to break the bond. That is what the boiling point will be very higher for corresponding alcohols. Are you able to understand, students? So here it is only weak dipole-dipole interaction. That's what we can break it easily. But in this case, the intermolecular hydrogen bonding will be very strong between the intermolecular, in the sense, what is that? The forces that are existing between the molecules. So the two molecules are existing or combined with each other, which will be having a strong interaction with the hydrogen bonding, so that we are not easy to break with the less amount of energy. We need to supply more amount of energy. That is what the boiling point will be very higher. If you don't know about this concept, please go and watch my previous video like intermolecular forces. And next one is distinguish between the following. This question was asked in the year of 2015 and 16. So here one ketone is given and one aldehyde is given. Okay, so we have to test it for aldehydes and ketones. So suppose if I am taking aldehydes, so what is the test for aldehyde? If suppose if I am taking RC6H5 C double band OH. Okay, so if it is react with, if suppose this aldehyde, if I'm using strong oxidizing agent, it will get converted into, what is that? Acids. But ketone required strong oxidizing agent, but our aldehyde not required strong oxidizing agent. So even a weak oxidizing agent, also mild oxidizing agent itself, it get oxidized, but the ketone does not give that kind of products. Say for example, if I'm using a tolerance reagent, okay, so it will be getting a product C6H5 C double band O binyl, so it will be getting oxidized. Okay, are you able to understand, student? So for example, if aldehyde will be taken, so the mild oxidizing agent is enough to oxidize this thing. So tolerance reagent is a mild oxidizing agent, so it will get oxidized this aldehyde into carboxylic acid. Okay, but in the case of ketone, does not require mild oxidizing agent, does not get oxidized. It required a higher or a strong oxidizing agent. In that only that ketone will get oxidized. Okay, that is what this is the distinguish. This is a test for finding out the aldehydes and ketones. Say for example, if I am taking aldehyde, so I am taking suppose C double band OH, it's a general formula. So along with that, if I am taking AgNH3, that is twice, and plus is there. Okay, this is nothing but a tolerance reagent. In presence of base only this reaction will be taking place. So I will be getting the product. What are the product I will be getting? RC double band O minus, along with ammonia is liberated, with that water is getting eliminated, with that the very important product what I am getting here is Ag. It is a silver mirror test. So Ag, silver I am getting, that is a silver mirror test, which will be otherwise called a silver mirror test. So this is a good identification of aldehydes, but ketone does not respond this test. Okay, that is a test for aldehydes and ketones. Suppose if they are giving aliphatic aldehyde and aromatic aldehyde comparison, at that time we have to check with the tolerance reagent if whether it is an aldehyde or ketone. The two compounds are aldehydes or ketones. Suppose they are giving aromatic aldehyde and aliphatic aldehyde. So these tolerance reagent will respond for both aromatic and aliphatic, but in the case of after that second iteration, what is that? Filling. If you use fillings, we can find out both the things. This is whether it is aliphatic and aromatic. We can check with that. Next one is that name the reagent used to convert the following. So here, what kind of reagent will be used? So ketone get reduced as alcohol. So we are in need of a strong reducing agent. Likewise, I can use lithium, aluminum hydride or sodium borohydride. So we can use this kind of a strong reducing agent. By that way only you will get this product. Let's see the mechanism. So here CH3, C double band O, CH3. Okay. So if lithium aluminum hydride will be getting separated, Li, Al, H3 plus and H minus. Okay. Now this H minus will come and attack this carbon, because that is the electropositive one, because it will be attached with the oxygen, which is highly electronegative, which pulls the electrons of hydrogen, so that this carbon will be slight positive and this oxygen will be slight negative. That's what this H minus will come and attack this positive carbon. Okay, now let's write the reaction. That is CH3, C and O minus. Here also one CH3 is there, and added hydrogen is here attached to this. Okay. And next one is here H3 plus is there, that will be attached to this minus. So I will be getting a product, that is CH3, C, O, Li, Al, H3 along with CH3. So here H. So if it is acidified, so if I am adding acids in that, this will be picking by the way of donating these electrons. By that way I will be getting a product, that is CH3, C. So here it is H, here it is O, and one more H is attached. By the way, the positive charge is getting created because it donates a lone pair of electron. That's what it attains positive charge. Here Li, Al, H3. The H plus now only it comes, so it won't leave as it is very fast, so that this LiAlH3 plus will move. By the way, the positive charge is getting neutralized. By the way, I'll be getting a product. Here one CH3 is there. Are you able to understand? So here CH3 is there. By the way, I'll be getting a product CH3, CH, CH3, and here it is OH. That is what my ultimate product. What I'm getting, my product I'm getting here is the same. That is CH3, CH2 degree alcohol I'm getting. Are you able to understand? And next one is aldehyde to alcohol. So we are in need of some reducing agent. Am I right? So here we have to check. Here also we used a reducing agent, but the thing is here we used the 3 carbon atoms, the 3 carbon atoms, so that we can use lithium aluminum hydride, that kind of a strong reducing agent. If we use that, C double bond group can be converted into OH group. But in this case you should note very clearly, here in this reactant side we have only 2 carbon atoms, but product side we have 3 carbon atoms. So we have to add one more carbon atom along with the reagent, then only you'll be getting a reduced product. So now we can check what kind of product we can use. So CH3, C double bond OH is there. So if I'm adding CH3 MgX, though this will be acting as a good reducing agent. Now I will be getting a product that is CH3, CH, so here OH and CH3. Okay, in what way I will be getting this product? Now we can check. So this is having minus charge because it's having 2 plus and having minus charge. So here this OH minus will come and attack this minus charge, will come and attack this positive charge. By the way, I'll be getting CH3 CO minus, and here it is H, and this CH3 will come and attach. So here positive charge is there. This positive charge will be attached with this oxygen minus, so that it will be giving MgX. So this will be, I'll be getting adduct. So this will be getting adduct I'll be getting. So this formed adduct will be hydrolyzed with that H3O plus. So here it is H, here it is OH. I'll be getting a product CH3, C, CH3, H. So here it is OH. So I'll be getting 2 degree alcohol here along with Mg. Here it is OH and it is X. So I'll be getting a alcohol. This is also a 2 degree alcohol. What is the product I'm getting? Total number of carbon atoms 1, 2, 3, 3 alcohol, 3 carbon containing alcohols I'll be getting. Are you able to understand, students? So here thank you so much for watching. Please don't forget to subscribe my channel. Thank you so much. Please go forward to others to get benefit. Thank you once again. Thank you. Thank you for learning. Share and like this video.